Okay, sounds good. Welcome everyone. Let's start with company update.
So I agreed to overpay for 100 GPUs. So we're gonna get 100 overpriced GPUs.
Oh, the 5950.
Yup. Oh, this is just. And then the tariffs are gone, and then the tariffs are back, and then get fucked. You're paying more. That's the only lesson I took away.
Wouldn't it be nice if there's like a GPU future price that you can lock in?
Well, that's what I thought having a signed contract was, but nope. Rugged.
Okay. Do you know when will we be getting those machines? I mean GPUs.
Nope. Oh no. You don't get to know that either. You just get a higher price for some GPUs in the hypothetical future.
And when do we need to pay? Like a wire?
Yeah, well, at least we don't have to send the wire until they're ready to ship.
I
But they
see.
just want to
Okay.
lock us in at the higher price. Yep.
Okay. Let's hope that's for the only this under and not the next, I don't know, few hundreds.
I mean, their guess is as good as mine. You know, if this stuff actually stays, everything's going to get way more expensive.
Yeah. Okay. We'll see how that goes. So what do we do with the V2 orders? We increase the price?
We'll probably end up increasing the price of the box, but I don't know. We only have two. I'm going to honor those. I'm going to honor those two. I'm going to honor those two at the original price. The two that actually paid. There's two that paid in full, and I'm not going to raise the price on them. But two new people, yeah, the price will be higher probably.
Okay. That sounds fine. Okay, let's move on. You want to talk anything about the chip?
Well, yeah, I mean that's kind of the. I don't know. The more I think about it, the more I think we actually are going to do a chip. It's like it's not that crazy. I see all the steps that it's going to take to get there. We're not going to do it soon, but I think we'll get to a point where it's almost just so easy to do a chip. We still have to solve the like. I had a good conversation this morning on custom hardware with Fleetwood. Uh, Maybe we don't need an L2 cache. Like GPUs all have this L2 cache. If we don't need an L2 cache, if we don't need an L2 cache, Tens Torrent looks a lot more attractive. Maybe Tens Torrent just kind of does have it figured out. I mean, I still want to get to the point where we can have our own chip, but this is going to be very like simple when it's time. If we could build something that just has to tile, we build one simple core. And there's no L2 cache. There's like global memory, but we can even hang it off an edge like Tens Torrent. If we can do all that stuff, then yeah, making a chip becomes a lot simpler because the key to making chips, it turns out, is that you want to do these shuttle runs. So if you have a chip that's just the same design tiled over and over again, you can actually get that small design taped out quite cheaply in a shuttle run where you share the shuttle with everybody else. And this is on the order of like it's like 300K for 6 nanometer even. And that prevents another big cost of these things, which is IP blocks. If you want DRAMs and networks, you need to pay to license analog IP, and this is millions of dollars. But if you're taping out what's basically pure digital and all you want is like SRAMs and some LVDS to talk to an FPGA, that's all included in the library with the that the chip manufacturer gives you. So yeah, I see all the steps to get there. It's all a software problem. We need to Tinygrad needs to be basically outputting fast assembly for GPUs and DSPs. And then once we're there, maybe we'll even need a tens torrent backend before we do our own chip, right? There shouldn't be. It should just be so easy to build these backends once we have the right libraries. That, yeah, that's kind of then we're ready to make a chip.
So as assembly backend, then maybe something like a tenstorrent backend.
Yeah, I mean, there
Because
has to be no reason we can't support tens torrent. Tens torrent is, if you thought DSPs were hard, get ready for tens torrent, which is even harder.
we
Like
got
at
this
least,
pretty much figure out.
we got what?
So we got DSP pretty much figure out.
Oh yeah. We got DSP pretty much. Well, not exactly. You can look in that branch. There's a lot of hand coded crap for that one model.
Yeah. I
Uh,
mean, of course, there are DSP specific instructions that we are not like fully using those, and maybe
those
there are some
are
upcasting stuff that needs to be done, but it seems straightforward. I don't know.
well, those are not even that. The instructions themselves are pretty simple. It turns out that data flow. It's not like the instructions are just basically different ways of triggering ALUs, whatever. It's not that important. What matters is your data flow. What matters is think of how your data is flowing through your whole network, and then think of what your. So the Qualcomm DSP has this 128 wide vector register, and then the main instruction that gets you flops, the DSP tensor core, so to say, it's not really a tensor core, is this multiply two vectors together and then do 4 wide reduces. Like take each chunk of 4 and then reduce that into an 32. And that's like the main instruction. So now optimize everything to use that instruction, basically. But the DSP forced us to only soft consider memory. So I'm using, there's an L2 fetch and an L1 fetch instruction, which will prefetch things, and you have to use them in order to get speed. But you don't have to use them for correctness. I think we'll get to a point where, I mean, you got to make sure that you're doing those fetches perfectly. Things aren't falling out of the cache, right? This is where software needs to get to kind of before. So yeah, like getting perfect speed out of the DSP is kind of a prerequisite for like our own chip.
And kind of don't have a good cost models for like these memory fetch thing. I think you just check their generated code and hand tune those.
It's not even that, like it's basically just if you're going to access something, you want to do an L2 fetch command 100 cycles before you access it, and you want to make sure that the size of your L2 fetch is like under 8 kilobytes or something.
I think
Just
we'll have a
basically those two
very
things.
yeah. I think we will have a similar-ish problem in like multi GPU or even multi machine. There are usually places like you can decide your copy order and your compute order.
Yeah, it's all the same problem, just repeated over and over again at different layers of the
Great.
stack.
Great.
So yeah, no, and until like, I mean, in some ways, tens torrent maybe just is the right design. Like tens torrent is the ultimate hard one to code for, but fundamentally, look, like Google's like the TPU is almost easier to code for than tens torrent, but the TPU scale out is a mesh, is a torus, the same way tens torrent is a torus. So you're not getting any benefit to just like, even if you don't have to use the rings on the one thing, if your fundamental connectivity is going to be a ring, which I think it has to be, then why not solve the ring problem at small scale too? So yeah, Fenstone has it right.
Cool. Great. Okay. Anything you want to say for fast Python?
Yeah, you can read it's FP underscore match. I'm almost ready to merge it. I don't know why this autogen test is flaky. I don't know why some of these tests are flaky, but why is this test flaky? setup environment keeps failing. I don't get that, but and yeah, I have to make sure this benchmark test passes. But it's about 30% speed across the board Python time. So it should reduce Python time 30% on everything. And you can try
Is
it.
that okay? Is that the case for Llama? Like NGT Llama?
It should be, yeah. It should be.
Okay.
So about half the time was spent in Match, and Match is now like 4x faster.
Great. You can claim the bounty once you merge that.
Yes.
I guess the first two.
Yeah, I can claim the first two, and the last one's doable too. So like, I've still kept it to basically what I'm doing is just compiling the UPAT to a Python function. And I can go further. I can go way further with this. Like, there's so far you can go down this rabbit hole of realizing that the UPATs, like currently I'm just looping through the UPATs and matching them. You don't have to do that. You can design it's a decision tree basically. You can factor some decision tree. You can figure out what your branching factor can be. You can start doing dictionary lookups, or I don't know if the match case statement in Python is fast. Hopefully it is. Hopefully that's basically O of 1 and not O of n. But yeah, you just got to start doing micro benchmarks. Diminishing returns at this point, though. Most of the slowness is just in.
You use the Python match.
I compile Python. I just generate Python.
Yeah, I think Python match is fast.
What do you mean Python match?
Also use Python's match statement.
Oh, I don't use Python match, but you can use Python match.
Oh, okay.
I don't know. Yeah. Is match case better than a whole bunch of nested if statements? Hopefully it is. But you got to start doing micro benchmarks to get this stuff. But 8x was definitely possible. That was a totally claimable bounty for anyone. I don't know why nobody did. It wasn't that hard. It took me a week to get $2,000. So. Okay. And it didn't really require specialized knowledge. So I don't I'm surprised no one claimed that bounty. It just wasn't that hard. And then you can push forward into compiling these things all together. I can also start. So right now I'm still doing a function call to the function that the pattern matcher but say you have something dumb like x plus 0 is lambda xx. You should be able to look inside the lambda xx and be like, oh, wait a second, I can just return x if I ever see this pattern. So that's another optimization here that'll get you a couple more percent. But I think the main thing I'm going to look at for the rest of the week is the linearizer. Why is the linearizer so slow? I can make that twice as fast. There's another 10% to overall speed, 20%. Yeah, so good progress on that.
Excited. Okay. Next we have our BERT and MLPerf. I post the current status for our 3 system during the weekend. I run so for BERT MLPerf we need 10 back-to-back runs. Previously we used 2-3 machine and run for 2-3 days. Now it's slightly faster, so I generated the runs. For the MI300 ones, everything looks fine. It's pretty stable. I imagined maybe with the Python speed or some small tuning, it can be less than 100 minutes. Any green, similar story. Also relatively stable. That's nice. And so all our conversions is, I don't know, 20% higher than the reference, but the reference is also, I don't know, it's reference. I don't see other people hitting that number. They are also using larger batch size, so I don't know. The red is the one that I was struggling with because so for one thing, if a red machine hangs, it doesn't crash the process. So I really need to check if it's hanging. That's one thing. I added a check to crash if the loss become nan. Then I got I got a bunch of nans from AM driver. That I'm not sure if it's AM only, but previously I was running using AM for beam search and setup and using AMD to to run, and that seems fine. But again, each full round took 6 hours, and I don't even know if it's like some machine is bad or something. So, I think for me, I'd like to. So I use the MLperf logging checkers to make sure for the MI300X and the green that I have like 10 rounds. All the rounds are logged correctly. The numbers are fine. So these two I have like more confidence now. The red, since it's the I really want to submit with our own driver, and I'm happy to like help testing it or like spam running these. But it's really not stable and it's still like a 5% slower than AMD. Yeah, so for me, I'm making sure these looks stable and fine. I want to like add some of the fusion tricks that I'm adding. There are some weird problems in my runs that I will try to find a smaller repro and see how we can fix those. Let's Bert.
Cool. Sounds good.
Yeah.
Yeah, I don't know. Why is the AMD one nanning?
So
are you using FP32 output tensor cores?
no, it's FP16, but again, the same code runs.
Oh,
No, the same code runs with Screen.
no, I understand, but NVIDIA's tensor cores are more numerically stable than AMD's.
Oh, is there a document on this?
Yeah. No, but it's just because of how they work. I mean, it's like so the RDNA3 tensor cores aren't real. They're just using the ALUs. So there's no actual instruction on RDNA3 which does this like cross reduce. So it's just feeding it back into the ALUs, whereas the NVIDIA tensor core is doing an actual reduce on the width of the tensor core, and it can like add them up all at once for the maximum numeric stability.
I see.
It's just
Okay.
fixed in RDNA4, but yeah, no, the RDNA3 tensor cores aren't real, so I would really use them with FP32 output if that's easy to change.
Okay. If we want to do that, I was also looking into like how to fix the don't realize expanding. That certainly save memory, but it double the speed on some other kernels. I can look into this and
Well, I
okay.
mean, we already
Now,
have to for the MI300. We already have to do FP32 accumulate. There's no FP16 accumulate.
but for the smaller tiny bucks, we are bound by memory, so it's a lot slower.
Yeah.
We need to drop.
How about
Yeah.
this? You can just hack the tensor core if you want to just use
Yes,
the
I was
FP32
thinking
accumulate one.
about
Yeah.
that. So,
It shouldn't change the memory at all. If something's changing the memory, something
I
else is broken.
understand.
But yeah,
Yeah.
you can't really use the FP16 accumulates on red.
Okay. If you okay, that's that might be the reason. Uh, I don't know. I can try that, and maybe later, when we talk about RetinaNet, we can also discuss because RetinaNet also has some NAND issue, but I'm pretty sure it's using flow 32 for accumulate. So there might be like fundamental issues in the red stack, but I would try the tensor core swap thing alone.
Interesting. Yeah, I mean, there might be other issues, but I do know that the tensor cores, I mean, they just have to be less numerically stable because of how they work.
Okay. Yeah. Okay. That totally makes sense.
I don't know if that's it. I mean, it could totally be that we're so far within a realm of, yeah.
Yeah. Okay. No, that's a good enough
By the way, are we
idea.
running with the same seed?
What's that?
Do we run them with the same seed? Like, is it reproducible?
Not
Like the
really.
NAND issue?
Not really. I mean, I'll think about if there's a way to make it reproducible. For now, the thing I'm seeing is it starts wrong and all the metrics look fine, but like an hour, 2 hours in, it suddenly get an epoch less than. So I think previously people hack around this by saying, you can. This is how people previously do mixed precision training. that you can kind of undo your update if you have a 4 or less NaN or something like that. But at this point, I don't really want to change our model code. So
I'd much rather just fix whatever's changing the memory ready to accumulate. Yeah.
that too. So I will look into like what's causing the issue with don't realize expand. And I mean, that's something we long term want to fix anyway. I think that's the most important thing. Then doing wrongs, making sure they are fine. And if possible, I want to get like 1 or 2 fusion thing in.
Cool.
Yeah, that's my plan. And with that, let's move on to scheduler.
Kazal said she couldn't talk on the meeting.
Oh, okay. I think she's working on kernelize and multi-output.
I'll do if for those that don't know what kernelize is. So right now, every tensor goes through 2 steps. It has a schedule step, which outputs schedule items, and then a realize step, which actually compiles those schedule items and runs them. We're going to add a 3rd step, where basically schedule does 2 things. Schedule groups things into kernels, and schedule also topo sorts those kernels and determines a linear order to run things in. So we're going to separate those into separate things. We're going to have 1 step, which is going to group things into kernels. That's the grouper. It's called kernelize. And then a 2nd step, which does the topo sort and actually outputs the schedule item, and we'll call that scheduling. So that's what that is. And then multi-output is multi-output from 1 kernel.
Okay. Let's move on to driver.
Yeah. So for the build, so yeah, I'll take a look. So actually, the first slowness which is fixed, it was because of the ring reduce. So the GPU was poorly sorted, and because of that, yeah, we couldn't do ring reduce in optimal way. And another 15 milliseconds, I think 10 of them is from the GPU kernels. I'm not exactly why. So actually comparing kernels from AM and AMD, they're just different in numbers. I mean, they're reproducible. Like, I mean, time is reproducible in AM, reproducible in AMD, but yeah, they're different. Some faster, some slower. So
That might have to do with the beam search.
No, I use the same one. That might
it's
be
not
the
the beam.
memory
Okay.
layout. Yeah, that might be the memory
Got it.
layout. Yeah, this week I'll try to just get this kernel and try to compare them one by one and see. So maybe memory layout is worse in AM.
Okay.
Yeah. So yeah, for NANDs, I can try to. So the only thing I think I don't know, maybe that's synchronization, but it's just basically the same, like for AMD and AM. Or maybe it's also different memory layout if we have some page files or out of memory accesses. I'm not sure if we have any.
Yeah, so my impression is, I don't know if you at AM, we got some really weird, really big numbers out of a formula that doesn't make sense. For example, we compute the accuracy and the output number is like 10 to the power of 20 or something that doesn't, accuracy should be between 0 and 1. And we saw there might be some like sync issue or something just completely wrong. I don't know if that's like understood.
Yeah, I fixed something related to that, but
So I think we would know more when we run the Retina net on red, because I think there the error seems to be more obvious to see. We'll discuss this later. I think don't worry too much about the NAND issue. I would try to give you a repro or at least find a way that cause the issue more consistently. I'm doing these runs anyway, and I think once I have something that's more reliably reproduced, you can take a look. Speed you can already check, but for the NEM issue, I think it's already bad enough for me to run this. You don't need to waste time to also run that until I have a better reproducible script.
Okay, yeah. So for the USB GPU, it's currently hacky, but I got it running, so it just can copy onto device, and it doesn't turn the GPU off. So yeah, it's currently.
Wait, so it's working. You figured out how to get around the stall as well.
Yeah, but it's currently hacky. I just reset the USB connection right now, and still, basically I need to. Yeah, so I need to find a better way from the GPU to acknowledge the NVMe comments. And actually, I figure out that they use like two, uh, two, yeah, they actually have like two values in their controller, which is uh like wired to the doorbell. So they actually like not access. They use like this as fast path to access the doorbell. So this registers points to the like specific address which is expected in NVMe to have. So yeah, I still can get this work on the GPU, but I think it's pretty close. And I think once this works, I think I can acknowledge the request from the GPU. But yeah, currently it works, but it's just not the
Oh,
not the
so what do you mean? Acknowledge it from the GPU. You're gonna like do a GPU DMA command and like tell it to go do something, like tell it to copy something.
No, I mean, because the controller supports like one command only, so it just waits for its SCSI write to be acknowledged by the NVMe, so it can reuse this buffer later for other requests. So and actually the device
Yeah.
should, yeah.
So, but you're gonna actually have to make the GPU do that.
Yeah. I mean, we can
You can't
modify
you can't
from
write to
there,
it
like,
over the USB.
so, I mean, yeah, actually
I'm,
yeah,
if
yeah, I just try to do that. No, I'm not like. I mean, I just try to prepare everything before and then just send comment. Like,
if you want to modify the firmware so the thing that I was really worried about modifying the firmware before was that you were trying to add functionality. So that's really hard. If all you have to do in your firmware modification is patch out like one jump, I'm okay with that.
yeah, basically just not waiting for the GPU response, and that should be enough.
Yeah, if that's easy, if the thing that looks like the firmware change is a 2-byte change, I'm supportive of it. Especially since we're already locked to use a single version of the firmware. So great, we'll use a custom firmware, make the 2-byte change, but let's just not try to write functionality in the firmware because that's super hard.
Yeah.
But great, and then
Should be about
I
right.
think it. Yeah, it should be a whole 2 bytes, 5 bytes. It's not what I'm saying
Yeah.
is not 100 bytes. Um, if yeah, so then it sounds like it's just going to be a whole bunch of refactoring to support like whatever that DMA size is, and then we're going to have to chunk the DMA like that, right?
Yeah. Well, I mean, we currently do the same on like using the CPU. So
Well, sure, yeah, we'll
yeah,
just have to go
it's
smaller
easy.
probably. And then the how long is it going to take to cold boot the GPU?
I haven't played with this. I mean, I don't know if we can reorder some IPs. So yeah, I haven't tried that. yet.
Yeah, I mean,
So
we gotta make sure that's like on the order of 15 seconds max.
yeah, sounds doable.
Cool. I mean, maybe. UUVN says he found something on the MI300 that just loads firmware, no PSP required. That'd be great.
Right, yeah.
You think it's real? You think it's on the GFX 11 too?
Yeah, they do have they have direct option to load firmware. But
Oh,
it's when I just looked at that, they have a bunch of commented code. So yeah, it simply doesn't work out of the box, like in their driver. Maybe yeah, we can get this working. I don't know. They actually use
yeah. I
this
think it's.
part for APU, but
What's APU?
I mean like when it's integrated GPU, like CPU and GPU.
Oh, I see. Yeah. Like the. Oh, so they do this for like the when you have like the Ryzen chip.
Mm-hmm.
Yeah, I mean that chip's going to have the global PSP as well. That chip's going to have the other PSP on it. It's going to have like the CPU PSP. But I'd be super happy if we didn't have to load the PSP on our GPUs. Like we should just be able to like not load it, right?
Yeah.
Yeah, that'd be great. Well, and then also then we can load anything we want. You can write custom firmware on the GPU at that point.
Yeah, because currently, yeah, PSP. I just tried PSP validate and binaries. So yeah.
Yeah, and custom firmware on the GPU is a lot more interesting than custom firmware on the USB thing. I mean, who wants to deal with like an 8051 and the branch tables or whatever? The GPU is just RISC-V.
Yeah. Yeah, I know there is a bounty, but you have to use B. I can try that.
If I would play with it for a couple hours. If you don't find it in 2 hours, leave the bounty. If it turns out it was just 2 hours, then I think it'll save you time on the USB.
Yeah. Okay.
Cool.
Okay, let's move on to web GPU.
Hey, so I don't have much to say about web GPU since last week. I've been working on some smaller PRs involving memory that are mainly helping me learn the code base. One of them is related to the bounty that was posted last week. I think I fixed the issue where Viz is blocking GC of buffers, and I added some tests. That's in one PR. I'll try to have that cleaned up and ready for review within a day or so. And another PR that might save some memory, but not sure it's going to be that impactful. I'll see if there's a simple way to include it. Otherwise, I might just close it. But yeah, just these things are useful for me to learn about the code base, and are helping me understand, like, for example, I think for web GPU, we might define, or for exporting models, it might be a more useful way to define the buffers we want to export, just in terms of them being referenced by UOP and not being an input and or output. That might be a simpler definition than what we have now. So yeah, that's all I've got to say.
Cool. Yeah, I'll look that PR over when it's ready.
Okay, RetinaNet.
Hello. So I think not right now. The main PR has been merged, so that's step one. Right now, I think what Chinese said on the Red Internet channel just mainly focus on getting the tiny box red runs going, especially with FP16, because I think there's definitely inconsistent losses. One whereas NAND for the AM driver and then the AMD driver wasn't. It was going, but but I think we just need to make sure that it actually converges as well. So I'm going to put up smaller PRs, just kind of add some sort of debugging flags to the main training script, so that it's easier to figure out some of the issues there. And I think when Chen Yu ran the eval beam, I think on the last run that he had that converged, it worked for him. So I'll just make sure that it actually is consistent for my end as well. And yeah, keep going on that.
Yeah, I don't think eval beam was doing anything. If you check the graph in my second round compared to my first round, I don't think the eval time changed at all.
Oh, okay, interesting. Okay, I can take a look into that for sure, because
Yeah,
it was
so-
definitely feeling for me.
Yeah, to reiterate what I said in the RetinaNet channel, I think so two things I think are the most important. One is the eval speed, and another is making sure Red can run it. So I think you can add some like dev beam or dev run script like we have done for ResNet and BERT. I think that's useful for other people to reproduce the run, and especially good if you can make like empty input for the beam run so that people can run it as a benchmark or see if it runs at all without downloading the data. Downloading the data is like 4 hours of work. Or I guess copy the data. But making sure it's like easy and we have a simple way to run benchmark, I think helps other people to run the script and see what the issues are. For the eval speed, for now it's like 120% of the training time. That's ridiculous. I think it can be much shorter. So check how other people's run look like, comparing like their training time and eval time. And as you mentioned, if like NVIDIA has their own libraries or their way to run the eval, we should just be able to copy what they are doing.
Yeah, I think a lot of the reference training implementations I've seen, which is pretty much based off of NVIDIA, they were pretty much using their custom implementation of it, which is parallelized PyCoco. So if anything, we can just kind of use that as well. But I think I'll put that as the very last thing for us to add. But I'll definitely focus on the post processing stuff, which is pretty much the chunk of the eval time.
Also, you are saying we are doing stuff in between running inference and coding the PyCoco tool.
Yes, exactly. So I think there's
Yeah.
like a function called post process detections. That's where basically the NumPy code is at. So that was pretty much the biggest bottleneck there.
I see. Okay, that sure sounds good. Yeah, fix that first.
Mhm.
Oh, sounds good. Okay. I see some update to the Torch front end multi GPU is from 2Cube, but I don't know if it's here. And also UUVN is not here. So maybe next time I will let him know early. B1TG, you want to say something?
Okay. I collect the modify the AST during the butter benchmark, and I found few cases are slower than the AMD backend. One is that heap split big loop during the VM frontend, which will not happen in the LLVM compile stage. The loop count can be divided by 6, not 4. So I will optimize and not unroll the big loop. So I temporarily add 6 to the list options to make it faster.
I see. So you think that HIP is doing some unroll that is not being done with LLVM, and you can do it explicitly in LLVM using our stuff. All right, cool.
Yes.
Yeah, I think for issues like these, it would be useful if you just add some benchmark script in like Tinygrad or even as a separate example so that people can run and can compare. That's
Mm.
sounds
Currently, it's in my PR.
I see.
There is a benchmark script. Should I push the collected functions to the repo? I
Wait, which
collected
PR are you talking? Which PR are you talking about? What number? I don't see a PR here from you.
One speed PR.
One speed PR. Oh, there we go. Okay, I see it. Cool.
And there are another functions that have many add and multi ops. It's like 1,000 lines of LLVM IR code. The heap reorder those options to make it faster. I still figure out why it happened.
Cool. Yeah, I see where you added the splits to the hand-coded optimization stuff.
Yes.
I mean, I'm really interested in why things are slower after Beam.
And after add 6 to the split option, the AMD backend also gets speed up.
Yeah, but again, so this is like all the hand-coded optimization stuff is not what happens when things are beaming. The thing that I'm most interested about is beam equals 2 speed. Hand-coded optimizations are just kind of luck whether they're good or not.
I'm not tested with the beam.
Yeah, see, the beam thing is the fundamental thing I care about. Yeah, you should be able to just. I think this script approach is a good idea. It's the same one we had for the PTX and CUDA. Yeah, so just throw beam equals 2 on there and see how things are going. And if you find ones that beam to something slower, then figure out what's missing.
Okay.
Cool.
Sounds good. Okay. That's it.
I could say a little stuff about the cloud.
Sure.
I mean, this buffer change looks good. I don't really know why I didn't do it. Probably for some image crap. So that can go, and then yeah, cloud graph. Yeah, it's a lot of lines. I don't know. Like cloud graph kind of points to this what really is graph. I don't know. Maybe I should just merge it and we can refactor it later. Like cloud graph is kind of the idealized graph from the 9876. Yeah, I don't know about that, but definitely the buffer one is a good place to start, and I like that. UVM's looking at cloud because cloud is how we're going to support scale out.
Yep.
I also just merged the fast pattern matcher. So I don't know what's wrong with the setup environment thing, why that keeps breaking, like why that's so slow. But everything else looks good. Everything else looks faster. I mean, we traded off some lines and some startup time for Python speed.
I also tested MOE. I think MOE on master for some reason is 10% faster than that PR. So try sync and see. I think
Yeah,
with fuse arrange on embedding and the fuse arrange change inlet gets like 40%.
Cool. Yeah, I've made a new channel, the general ML channel. It's for Tinycorp developers if you want to talk about just any general machine learning stuff, high level technical stuff only. But yeah, no, this Apple paper is wild. That MOE models scale differently from other models. And they seem to be like, my understanding of that paper says that MOE is way more data efficient than non-MOE. I'm like, yeah, you can kind of imagine why. Good that it's getting faster. For other bounties, if someone can get, oh, by the way, please, if you are submitting a PR that you did with AI and you don't understand the PR, don't waste anybody's time. Like, I'm not an idiot, you know, you're just wasting my time. You're wasting your time. You're wasting everybody's time. I'm not saying don't use AI. I'm saying if you use AI and get something you do not understand, I do understand it, and you look like a clown. So yeah, and that's generally true for people who use AI for other stuff too. So, you know, just general, please don't use AI unless you know what you're doing. So for open bounties, $500 if someone can get flash attention to work. It kind of works. All the infrastructure is there for it now. I think it's doable with a few days of work. If someone can figure out how to run unsigned firmware on the 7900 XTX, that was discussed a little in this meeting. Whole bunch of Torch backend stuff still. There's 4 of them up there, if anyone can do them. The GC one, I will lock that to Hooved, since there's been good progress there. If someone wants to get Llama 4 Scout running once we have MOE stuff, $500. The CPU graph one, I know there's a PR for that, but I think I closed it this morning. Please read your PR. Like, if you are copying and pasting stuff tons of times, even in the test, please refactor it. $300 if someone can get 5090 support in the NV backend. I think you basically just have to add one class. You have to add one like data type for the launch struct, so it's not going to be too hard.
I think the difficulty in that is to get a 5090 first.
Yes, exactly. We also have. Did anyone get the tensor cores for RDNA 4? Oh, I see this is locked to B1TG. Is that? I don't know why it's draft. But yeah.
Oh, I can finish it in this week.
Cool. Sounds good. Yeah, that's locked to you. So I knew it was like a line or two. I don't know why this. Oh, I see why there's other changes. But yeah, it's just like some boilerplate and then like one basic line. Cool.
Oh, I will comment on the FP8 one. I see the author open a new one. I don't know. I think it's possible to split that into smaller PRs and making sure there's no bug.
Yeah,
no obvious,
like that.
Obvious bug. You can.
Yeah,
I think you can add the FP8 D type and making sure like any grad stuff without really computing those D types are handling those type promotion correctly, and add a support to that to the thing, something like that.
I think that sounds good. It's too big, and that's what happened last time. Yeah.
Yeah, and everything added should, in some way or another, be testable. I think last time there was on like Python backend cast thing. I asked why it was not tested, and the author says tested. And I was like, okay.
Last time the tests weren't even running. The 2 tests were called, and they just weren't running because actual CUDA is not installed. So yeah, and then on CUDA they didn't even work. So yeah, I want to see a lot more rigor around that PR in order to get it merged. I always like felt iffy about it, and it's not FP8 in general. I'm actually very excited about FP8, but I think it's the general quality of that PR that needs to be broken up into.
Yeah. Single authors here. I will comment on that PR directly later.
Cool.
Okay. And Z3 stuff. As Lycos will be ready by tomorrow. Okay, great. We have more pieces that render part of a tiny grad into something else. It's like the fast matcher is render into itself, and this S3 render into S3 statements.
Yeah. Yeah, the rendering into itself is fun. I'm using the pattern matcher in order to create pattern matchers.
Yeah, that's how compiler works initially.
Yeah, we have a great like general API for it. The worst hack that I put in is I use comp NE to mean comp EQ. Maybe we should just add a comp EQ op.
Mm-hmm. Wait,
Yeah,
what?
but then like, okay, you add it to binary, thinks it's slower. I don't know.
Okay, whatever. As long as
Everybody can enjoy. It looks like pretty much a 30% speed up for compilation, and it also looks like a 5% speed up for everything. So like running even looks 5% faster. You can see it in the benchmarks.
Great. I already started a test run Bert.
Cool. It passed process replay, so there should be 0 changes, but no find anything.
Oh, that sounds good. Okay. Anything else?
No, more speed this week. I'm gonna get that. I'm gonna get that external benchmark schedule under 500 milliseconds. So we'll get an actual full 2x across Tinygrad.
That's good. Exciting. Cool. Yeah, I think that's it for this meeting. Making good progress. I think we can do a maybe in 2 weeks after we are ready for MLPerf. Speed looks nice.
We do a what in 2 weeks? Oh, do a release? Yeah.
And I think that's it for this meeting. Thanks everyone, and see you next week.
Bye.